Welcome back to the deep dive. I want to start today with a mind-bending question. It sounds a bit like a riddle, but just bear with me.
Okay, I'm ready.
If you stand in front of a funhouse mirror, you know, those wavy ones at the carnival, they make you look like a squashed grape or a stretched out noodle,
Sure.
and you take a selfie, do you panic?
Hmm.
Do you, like, immediately call an ambulance because you assume your actual skull has physically changed shape?
I would hope not. I think most of us just, blame the mirror.
Right. We blame the mirror. We instinctively know that the image we see is distorted, but the physical reality, what these sources call the territory, is fine.
And that's the thing.
But today, we are diving into a stack of documents that claim modern physics, has been making that exact mistake for over 100 years.
It is a really bold claim. We're looking at a radical reevaluation of Einstein's special relativity.
Radical one.
Yeah, the source material comes from a series of papers on something called Dr. Akifumi Higashi's dense clock field, and a really unusual dialogue involving this persona, Xeonochat.
And when you say dialogue, it's not just two professors talking. The premise here is, well, it's wild. It's presented as an audit.
An audit, yeah.
There's an AI character acting as an independent space-time auditor. And it's basically subpoenaing the laws of physics to see if they hold up.
It's a very unique approach, and the central accusation of this whole audit is that physics is suffering from observational narcissism.
Observational narcissism. I love that phrase, but I also hate it because it sounds like something my therapist would accuse me of.
Right.
What does it mean in a physics context?
It means confusing the map with the territory. It's the idea that because we see something happen a certain way, due to a light delay or perspective, we assume the physical object actually changed to match our view.
So we've confused the delay of light with the actual bending of space itself.
That's the argument, yes.
Okay, hold on. We are talking about Einstein here. Special relativity is like the absolute bedrock of how we understand the universe.
It is.
Are these sources really saying Einstein was just wrong? Because that's a massive hill to climb.
They're suggesting he was half right, but he may have misinterpreted the cause.
Okay.
To understand why, we have to look at how these documents break down reality. They argue that physics gets messy because we sort of mash everything into one world.
Right.
But Dr. Higashi and Xeonochat, they argue they're actually three distinct worlds.
Three worlds. Okay, walk me through this. What's number one?
World number one is the mathematical world. This is the realm of the chalkboard, pure logic, geometry, formulas.
The sandbox.
Exactly, the sandbox. In this world, everything is perfect. You can rotate axes, you can have negative time if you want to. It's where the theorists live.
Okay, it makes sense. World two.
Then you have world number two, the physical world. This is the territory, the actual electromagnetic field. The atoms, the events, the collisions. This is what's actually happening, regardless of who's watching.
So if a tree falls in the woods and no one is around to hear it.
It happens in world two, exactly.
Okay, and the third one?
And finally, world number three, the observational world. This is the map. This is the image that reaches your eye or your camera.
And this is the one built by light.
Yes, and here's the crucial part they just keep hammering on. This world is constructed entirely by light, and light takes time to travel.
It has a speed limit.
It does. So everything in the observational world, everything you see, everything you photograph is old news. It's a delay. It's a mosaic of the past.
So the whole argument is that standard physics just blurs the line between world two and world three.
Precisely. Standard relativity says, if a moving train looks shorter to me, it is shorter.
Physically shorter.
Physically shorter. Space itself has contracted to make that happen.
And these sources say?
They say that is a category error. Just because the image is squashed doesn't mean the steel train car physically crunched up like a soda can.
It's map versus territory again.
It always comes back to that. It's a confusion between the delay of the signal and the reality of the object.
But, wouldn't physicists know that? Light delay isn't a new concept. We know looking at stars is looking into the past.
You'd think so.
So why would they confuse delay with physical shrinking?
That is where we get into the mechanics of it. The sources introduce a concept called Protocol 01. They call it the event anchor.
Right. This is where it gets really interesting.
It is because it challenges how we intuitively think about light.
Yeah, I had to read this part a couple of times. It's about separating the objects from the event.
Right. Let's try an analogy. Imagine you're driving a car down the highway and you toss an apple core out the window. What happens to the apple core?
Well, it flies forward with the car for a bit. It has my momentum.
Exactly. That's how matter works. But the sources argue that light does not work that way.
Okay.
Light is a wave in a medium, the universal electromagnetic field. So imagine a train moving down a track. A spark flies off the wheels.
Got it. Train moving, spark happens.
The event anchor protocol states that the moment that spark happens, the emission point, it is anchored to the universal field. It's like dropping a stone in a pond.
And the ripples expand from where the stone hit the water.
Right. And if the train keeps moving?
The ripples.
Yeah.
They don't chase the train, do they?
They do not chase the train. The ghost of where that spark happened stays fixed in the background field. The train moves on, but the light expands from that fixed anchor point in space.
So the train is basically leaving this trail of ghosts behind it.
Yes. The documents describe the universe as a point cloud. It's not a smooth, continuous film. It's a collection of dots events left behind in the medium.
Wow.
So if you're looking at a moving train, you aren't seeing the train where it is now. You're seeing a collection of light rays exploding out from those ghost anchors in the past.
Miles behind where the train actually is.
Potentially, yes.
Okay, I'm visualizing it. You have this train, and it's leaving these phantom sparks behind it. But how does that lead to the observational narcissism? How does that mess up our math?
It messes up the math because we assume the observer's perspective is the only thing that matters. And this leads us to the next big shift in the documents. The Wimbledon model.
Protocol 03.
Protocol 03.
I like this one because I'm a tennis fan, but it also felt like a direct attack on one of the main pillars of relativity.
Which is?
That all motion is relative.
It is a direct attack. Standard relativity says there's no absolute rest. If you're on a train, you can claim you are still, and the world is moving.
And if you're on the ground, you claim the train is moving. Physics says both are equally true.
But the Wimbledon model says objection.
Right.
It imagines the universal electromagnetic field as Wimbledon center court. That is the territory. It's the stage.
Okay.
Then you have the umpire sitting in the high chair. The umpire represents the absolute viewpoint static relative to the court.
And the players are the train and the track.
Exactly. And this is the twist. In this model, both the train and the track are moving across the court.
Wait, the track is moving too?
Well, in the context of the universe, yes. The Earth is spinning, it's orbiting the sun, the galaxy is rotating.
Nothing is truly static.
Nothing except the field itself, the court. So the track is a player running at one speed, and the train is a player running at another speed.
So if the passenger on the train thinks they're motionless, they're just wrong.
The sources call it a geocentric illusion. It's like believing the sun revolves around the Earth just because it looks that way from your porch.
Right.
The passenger feels still, but that's subjective. The reality, the territory, is that light travels at speed c relative to the court, not relative to the player holding the racket.
Okay, so we have a court. We have light anchors staying put on the court while the train runs away. This all sets the stage for the main event.
The paradox.
The one that tries to dismantle length contraction. They call it the banana face.
This is protocols 04 through 07. It's a thought experiment designed to show that length contraction is an optical illusion, not a physical reality.
Okay, let's unpack the banana face. We have a character, E093, that's the name in the documents.
Let's stick with that.
He's 1.67 meters tall. He's moving sideways past us at a very, very high speed, and we're trying to take a picture of him.
Okay, now remember the event anchor. Light takes time to travel.
Right.
So if E093 is moving past you, his head and his feet are not necessarily the same distance from your camera lens.
Right. If he's moving sideways, one part might be slightly closer than another.
Exactly. Even just a little. The light from his head has a certain distance to travel to get to your camera. The light from his feet might have a different distance.
Okay, so there is a distance difference.
And because light has a speed limit, that difference in distance means a difference in time.
So the light from his head arrives at a different time than the light from his feet.
This is what they call the asynchronous emission error. When you snap that photo at, say, time 10, the light hitting your sensor from the head might have left 1 nanosecond ago. But the light from the feet might have left 3 nanoseconds ago because it had further to travel.
So I am stitching together a head from 1 nanosecond ago and feet from 3 nanoseconds ago into a single image.
And in those 2 nanoseconds of difference, the actual body moved. He's sprinting.
Oh, right.
So the head in your photo is in one horizontal position and the feet are in a completely different horizontal position.
So the image looks stretched or slanted or squashed.
Depending on the angle and speed, it looks like a banana, but And here's the million-dollar question. Did Cyanochat's skeleton physically warp into a banana shape?
No, of course not. It's just lag. It's like when you drag a window on an old computer and it leaves that trail. It's a glitch in the display.
Precisely. It is a motion blur artifact. But the sources argue that standard physics sees this distorted image and invents a physical law-length contraction to explain it.
Instead of just checking the timestamps.
Instead of checking the timestamps.
That seems like such a huge oversight.
Yes.
Are we sure it's just an illusion? How do they prove it isn't physical?
They use what they call the multi-observer verdict, or Protocol 06, and I think this is the strongest argument in the whole stack.
Okay, walk me through it.
Imagine we have 3 photographers, A, B, and D. They are all standing at different positions along the track. They all take a photo of our runner, Cyanochat, at the exact same moment, T10.
Got it. So photographer A is close, photographer D is far away.
Right. Because they're at different distances, the light lag is different for each of them. Photographer A sees ahead from maybe 0.1 seconds ago, but photographer D, being further away, sees ahead from 5 seconds ago.
Which means they see the runner at different positions in his stride.
And crucially, the amount of banana distortion will be different for each of them. So photographer A might calculate his height as 1.65 meters.
Okay.
Photographer D might measure the image and get 1.60 meters. A third observer might see him as 1.70 meters.
Wait, I see where this is going. If the shrinkage was a physical thing, if space actually compressed,
Then what?
everyone should agree on the size, right?
Yeah.
You can't be physically 1.65 meters and 1.60 meters at the exact same time.
Exactly. That is the checkmate. Physical reality, the territory must be consistent. It can't be a paradox.
Wow.
If observer A and observer D measure different physical lengths at the same absolute moment, then the change in length cannot be a property of the object. It must be a property of the observation.
It proves the shrinkage is subjective. It's an optical illusion that depends on where you're standing.
That's their argument.
Yes,
Yeah.
it actually makes a lot of sense. If I take a photo of a car and it looks small because it's far away, I don't assume the car shrank. I assume perspective. But relativity tells us the car actually shrank.
And Cyanochat is arguing that relativity is just a very, very fancy way of codifying that perspective error into law.
So we have identified the problem. We're taking photos without checking the timestamps, creating these banana-faced monsters. But the sources don't just complain. They offer a solution.
They do.
And this is where Dr. Akifumi Higashi comes in with Protocol 08.
The dense clock field. This is the fix.
It sounds like a sci-fi device. What is a dense clock field?
It's a conceptual tool. Imagine that we just wallpaper the entire universe, the court, with microscopic clocks. Every millimeter of space has a tiny digital clock embedded in it.
Okay. A universe made of clocks.
And these clocks are perfectly synchronized. They revive Galileo's concept of isochronism, absolute time. They aren't affected by how fast you're moving. They just tick away, measuring the absolute time of the universal field.
So now I take my photo of the moving train again.
Right. You snap the photo, the train looks squashed. Standard physics would say, look, length contraction.
But this time, you don't just look at the train.
You look at the background. You look at the wallpaper.
Okay.
Look at the nose of the train in your photo. Behind it, there's a clock on the wall. What does it read?
Let's say T10.
Okay. Now look at the tail of the train in the same photo. Behind the tail, there's another clock. What does it read?
Well, wait. Since the light from the tail took longer to reach me, that image is older. So the clock behind it would show an earlier time. Maybe T8.
Bingo! This is the smoking gun. The photo itself contains the proof of the delay. You are seeing the nose at T10 and the tail at T8.
So I'm looking at the front of the train on Wednesday and the back of the train on Tuesday.
Exactly. And you can't subtract a Tuesday position from a Wednesday position and call it length.
That would be like measuring how far a car traveled by subtracting where it was yesterday from where it is today and claiming the car is 500 miles long.
It's statistically invalid. But without the clocks, we don't realize we're doing it. The dense clock field forces us to normalize the data.
So you have to do the math.
You see the tail at T8, and you have to ask, okay, but where was the tail at T10? You have to calculate the distance the train moved in those 2 seconds and add it back in.
And when you do that, yes, the train unshrinks.
The train unshrinks, the paradox disappears, the banana face snaps back to a normal face. The math shows the object's physical length never changed.
We weren't accounting for the time gap in the pixels.
That's the argument.
This really shifts the philosophy of physics, doesn't it? It feels like we're taking power away from the observer.
It does. That's what segment 6 of our outline calls light as the protagonist. It's a complete role reversal.
Explain that. Because in relativity, the observer, the camera, is king.
In standard relativity, reality is defined by what the observer sees. If I see it shrink, it shrinks. The observer is the protagonist. But the Zelina chat sources argue that's arrogant. That's the narcissism.
So in the dense clock field, who is the protagonist?
The light ray. The light ray carries the information honestly across the medium. It doesn't lie. It tells you exactly when and where it came from.
So the problem isn't the light.
The problem arises when the observer, who is just a passive bucket, tries to rewrite the laws of physics based on the order in which the raindrops fall into their bucket.
We shouldn't blame the rain for the shape of the bucket.
Precisely. We need to stop assuming that our map, our delayed, patched-together image, is the territory. The territory exists independently of us.
And the dense clock field is just a reminder of that.
It reminds us that there is a physical world that doesn't care about our optical illusions. It doesn't care if we're moving fast or standing still. It just is.
It's humbling, in a way. It says the universe makes sense, even if our pictures of it are messy.
And that's a very Galilean idea, that there's an objective truth out there waiting to be measured correctly, rather than a subjective truth that changes depending on who looks at it.
It's funny, we started this whole deep dive with a silly image of a funhouse mirror.
And we've ended up dismantling the philosophy of modern physics.
Quite a journey.
It really is. We went from the three worlds, separating the map from the territory. We visualized the event anchor and how light leaves ghosts behind.
We looked at the Wimbledon model, the hierarchy of the court versus the players, which stops us from claiming all motion is relative.
Then we saw the banana face paradox, how asynchronous emission creates a distorted image.
And how the multi-observer verdict proves that distortion can't be physical because everyone sees a different distortion.
And finally, Dr. Higashi's dense clock field. The simple solution of checking the timestamps on the background pixels to unshrink the train.
It all just comes down to that one distinction, doesn't it?
Yeah.
Physical reality versus observational reality.
Just because you see it doesn't mean it's real.
The final takeaway for me is this. The shrunken train isn't some marvel of space-time bending. It's just a failure to check the timestamps. It's a clerical error.
It's a failure to recognize the delay, yeah.
So here's a provocative thought to leave you with. If length contraction, one of the absolute pillars of modern physics, something taught in every university, is just an optical illusion caused by light delay, what else is a banana face?
That is the big question. Time dilation, simultaneity.
Exactly. What else in our textbooks is just a funhouse reflection waiting to be unmasked by a simple background clock?
It makes you want to go back and audit everything, doesn't it?
It sure does. I feel like I need to apologize to every mirror I've ever blamed. Until next time, keep checking your timestamps.
And don't trust the map.